Okay, yeah, just got word that we're live on Discord now, and we'll be live on YouTube very shortly. So we'll start the event now. Today we're pleased to be joined by Celer team to discuss a bit about our recent collaborations on the Oasis Privacy Layer and the Oasis Sapphire network with both Celer IM Bridge and the Celer Token Bridge. My name is Will. I'm Ecosystem Growth Manager here at Oasis. And yeah, I guess my role is mostly to work in ways to strategize and help set priorities to help grow the Oasis ecosystem. We work pretty closely with this other team, so I'm excited to bring to you guys the work that we've done and host this event today. We're joined today by Michael Zhu from the Celer team. Michael, if you would like to introduce yourself.
Hi, everyone. This is Michael from Celer. I'm a developer at have been a long time with Celer, and yeah, thanks Oasis for inviting me. And yeah, we've been working very closely on some of the cross-chain like use cases of involving the both Oasis and like whatever Celer, the C Bridge and the Celer IM Bridge can do. And yeah, I'm very happy to be here to share some of our progress and kind of like show a little bit demo of our documentation, our code examples. Thanks.
Awesome, thanks. And Guan Yao, the Celer team as well. Oh, okay, maybe just join the team as a visitor. So anyway, the event today, we're going to mostly just be talking about Celer, but before we do, I'm going to give a brief overview of the Oasis Sapphire network, as well as the Oasis Privacy Layer that we've been working on. I'll share my screen in just a second. Yeah, so this is our sort of presentation on the Oasis network and the privacy layer for Web3. So what is the Oasis network? It's a privacy-first scalable architecture that for a layer 1 blockchain. So basically what that means is that we have a very similar architecture to maybe some of these other ones that have come out recently, like ETH 2.0 or even Polkadot. If you're familiar with these networks, we basically have an underlying consensus layer, which is sort of analogous to the beacon chain or the relay chain in Ethereum and Polkadot. Basically, on the Oasis network, our consensus layer just handles staking, governance, and validation of proofs that come from the execution layer. That might be a little bit different than like Ethereum 2.0, where the beacon chain has the ability for smart contracts. On the Oasis network, the consensus layer does not have the ability to create third-party smart contracts. But what that does is it gives us the benefit of super high throughput. So our consensus layer can handle 1,000 transactions per second, meaning that we have the ability to support many execution layers, as well as super high throughput through the consensus layer. Our execution layer is built up of parallel runtimes, which we call paratimes. In a lot of ways, they can be thought of as layer 2s or as rollups. In reality, they are pretty much rollups. Instead of an optimistic rollup or ZK rollup, though, they submit bare metal proofs, so a little bit different on that end. The idea of a bare metal proof is that essentially it allows for instant finality and pretty high transactions per second, in the mid hundreds, the 300 transactions per second with instant finality, whereas like an optimistic rollup can handle a bit higher of a throughput, but comes with like a 1-week finality. So that's sort of the trade-off we make there. Also, sort of this architecture allows us to be very flexible and support a bunch of different privacy technologies natively. And so we released an article maybe a year ago, which is basically explaining how Oasis is the only network that basically was built intentionally to support rollups. We sort of had the design from the very beginning. And basically the idea is throughout the network, we're going to have many different runtimes, and developers will be able to choose which runtimes best fit their needs and their use cases. Today, we're mostly going to be talking about the Sapphire paradigm, which is our most recent launch, and it's one that we're very proud of. Sapphire is a confidential runtime. So what that means is it's able to keep data private. This is done by using trusted execution environments, which sort of act as like a black box. So every single validator on our network runs these trusted execution environments. And basically the way you can think about it is that when transactions are submitted to the validators, all data is encrypted. When it goes inside the black box, it gets decrypted. Inside there, now it runs like a normal EVM, but no one can see what's going on. And then it gets re-encrypted as the output based off of the parameters that developers choose as well as the users. And so in this way, you can create an extremely scalable and extremely simple to use EVM runtime. It's offers similar levels of privacy to zero knowledge proofs, multi-party computation, and other privacy technologies. But we think that it decreases developer friction tremendously, as it can be EVM compatible. It can, developers can build in Solidity and also have they make use of all the sort of infrastructure and developer tooling that has existed that has been built for the EVM over the past 10 years. Things like MetaMask, Hardhat, Truffle, oracles, indexers, these types of things that are designed specifically to connect to the EVM, all sort of come out of the box with the Sapphire network. Plus, they now have confidentiality. So this is something that we're really proud of and excited to sort of launch into the world. So basically, the way we think about this is, what the Sapphire network offers. It offers scalability, so it offers super high transactions per second. It offers compute. It offers storage too, which a lot of other networks struggle with data storage, but sort of because we use this modular approach as well as bare metal proofs, we can handle a little bit more data storage. Privacy. So obviously we talked a bit about privacy so far, but one of the things that we often like to make it analogous to is this idea of, in Web 1, when the internet went from HTTP to HTTPS, this is like really when the internet took off. Basically, you couldn't have e-commerce before that because there was no encryption on what you were doing while you were connected to the internet. And so when you eventually were able to, when the internet moved to HTTPS, where now you have encrypted sessions, now we can really start expanding on the use cases. And that's really what I think Sapphire and the Oasis network is about. It's about enabling more sophisticated and more complicated use cases so that Web 3 can better compete with Web 2. So I think we've done pretty well so far with the ability for where essentially the Web 3 has only had the ability to do completely transparent transactions. Now with the ability to have transactions anywhere on the spectrum of privacy, so entirely transparent, entirely confidential, or somewhere on the spectrum between, we really now can start expanding on our use cases and competing on that level. And so finally, decentralized identity. I think this has been one of the long, difficult problems to solve in Web 3. Is this idea of how can we have an identity in the Web 3, but also maintain our privacy. And so this is something that the Oasis network and specifically Oasis Sapphire is trying to solve. So that's a bit about what the Sapphire network is. Now we'll talk a little bit about the Oasis Privacy Layer. Basically, the Oasis Privacy Layer came from this idea that we're very excited about Sapphire, but quickly we realized that the benefits that Sapphire has are not limited to just the Sapphire network. We can actually offer other blockchains, other networks, layer 1s, layer 2s, the ability to leverage Sapphire and expand their own use cases. So what use cases are we talking about? Some of the early ones we identified are DAOs. So for example, currently in Web 2 and Web 3, if you have a DAO, let's say on Ethereum, and you want to have confidential voting, that's entirely impossible, right? Because all transactions are entirely transparent. And so what the Oasis Privacy Layer can do is it can actually enable DAOs on other networks to have private voting without having to migrate the assets from the DAO over to the Sapphire network. This is really important, I think, because in governance, you know, in the traditional world, we pretty much see that all governance and all voting has some level of confidentiality and anonymity. And this is because, you know, over time we've learned that this is how you remove bias. When everyone can see what everyone votes for, it enables bias. You know, people don't want to fear the repercussions of maybe voting against their boss, or, you know, voting against their friend group or something along those lines. And I think we've seen this play out now in Web3 a few times. And so we get to now remove bias from the governance process, and, you know, at the very least offer a more flexibility in how DAOs create their governance processes. We talked a bit about decentralized identity already, but basically users can control their data with selective sharing policies, where they can basically revoke or disclose or enable people to access their data, which, you know, unlocks an entirely new potential for Web3 gaming. Basically, I think any compelling game has some aspect of confidential logic that it needs. So I know I was going to talk about like poker. If you have poker, you in Web3, it's not really possible, because because of the transparent state, you would know what the other player's hand is, as well as what card is coming next. So you can't really play poker. Real-time strategy games often have this idea of fog of war, where like units on the map have enemies hidden, or they have resources hidden that you can't see unless you're like within a certain distance of them. Again, not possible in Web3 today because of the transparent nature. And even like role-playing games, like have these ideas of quests, riddles, puzzles within the RPG. And again, this is not possible in Web3 today, because the solutions to those quests, riddles, and puzzles would be known, as well as the solutions that people submit would also be viewable. So even if you hit it off chain, if people made transactions on chain to like submitting their solutions, those transactions would be viewable. And then DeFi, obviously, you know, we've heard a lot about MEV, minor extractable value, and people sort of looking into the mempool, seeing what transactions you're going to make before you make them, and then front running you. And so all of these things can benefit from privacy, and we're excited that to release the Oasis Privacy Layer. So not just the dApps that run on Sapphire, but dApps that run on any EVM network can sort of start benefiting from these benefits, benefiting from these use cases. Sorry. So this is just a quick slide of some of the features. So basically, private variables are actually private and protected by Oasis trusted execution environments. It offers an identical user experience to Ethereum with near identical developer experience. The gas fees are 99.9% lower due to Oasis scalability that we talked about earlier. Also, because of the way that we use privacy, Oasis actually has built-in native random numbers generation. So this means that you don't need to use like off-chain oracles for on-chain randomness, but you can actually have it built into the dApp from the network itself. And this also enables the idea of like confidential randomness. So you can sort of, let's say, again, using the deck of card example, you could randomly generate the entire deck of cards, and then only like once every 10 blocks, let's say, a new card, the first card will be shown, and the second card will be shown 10 blocks later, and the third card will be shown 10 blocks after that. So you only have to generate the randomness one time, and it stays confidential until it wants to be disclosed. Disclosed. So it offers general purpose smart contract support. Basically, what this means is that you know, some of these other privacy solutions, maybe like ZK, they would struggle with creating like smart contracts that need to aggregate data from multiple parties. So imagine like a DEX. If you're trying to build a DEX using ZK that it has, you know, a private word book, it's extremely computationally expensive in order to do that, because essentially you have all this private data that has to somehow prove itself to one another, so that there's so that the state of the actual whole DEX at one time can be known. Whereas again, because we use the trusted execution approach, within the TEs, everything just runs like a regular EVM, and so it has the same level of general purpose smart contract support as well as composability as other EVM networks. So again, we talked about some use cases before. I want to give Michael some time to talk about what he's about the Celer aspect. So if I skip this slide, and I just want to leave you guys with this brief sort of outline of how we view things working. So basically, you can see that we're leveraging both gas relayers and a message passing bridge to connect dApps from two different networks. And so basically, let's use that RNG example from before, where you want to have a quest or a puzzle or a riddle, but you can't do this today on Web3. Maybe your RNG right now exists on Polygon, and you want to stay on Polygon because the users are there, the sort of NFT marketplace is there, and also all sort of the ecosystem composability is there. So you really want to stay on Polygon. You wouldn't switch to an entirely new network, port your entire game over just to have on-chain quests, riddles, and puzzles. But it is still a feature that you would like to add to your game, as this is sort of a cornerstone of the RNG genre. So instead of porting your whole product over to Sapphire, what you can do is you can launch sort of a parallel quest riddle puzzle smart contract on Sapphire, and then connect it with this message passing bridge and gas relayer. So the user experience would go something like you're playing the game on Polygon. As you're playing, you get to the point where you have to solve this riddle. MetaMask would automatically switch to the Sapphire network. On MetaMask, on Sapphire, you would submit your encrypted solution. No one would be able to see your solution. It's encrypted. You would submit it to a smart contract on Sapphire. If the solution is correct, the smart contract would send a message over the message passing bridge to Polygon saying, hey, they got it right. And now you'll unlock your NFT reward, let's say. And so, yeah, as you can see, the message passing bridge is a very large part of how the Oasis Privacy Layer will work. And that's why we're super excited today to have our partner, message passing bridge partner, Celer, here to discuss a bit about what they're doing, how to start building applications today, leveraging their bridge, and sort of unlock these new use cases. So thank you guys so much for the time. I hope this was a good overview of what we're doing with Sapphire and the Oasis Privacy Layer. And the floor is now yours, Michael, to talk about Celer.
All right. Yeah, thanks, William, for a very thorough overview of what Oasis does, and especially what the privacy layer does. Can you see my screen?
Yeah, I can see it.
Sounds good. All right. Yep. So I'll be just to briefly go over what Celer does, and especially what our starting from our token bridge to our interchain messaging bridge, and also the what the OPL, how the OPL leverages the interchain messaging bridge to sort of does the message passing. So sorry, my sharing is a little bit funky. Yeah. So first of all, what is cBridge? So the theme of cBridge is just the blockchains connected, and essentially cBridge is this interchain operating system that kind of enables this one-click multi-chain, one-click cross-chain user experience for any sort of blockchain applications. So whether it be fungible tokens, whether it be NFTs, or whether it be DeFi's governance, game, sort of all those use cases that William mentioned previously can all be supported by cBridge. So underneath, what cBridge is this thing called SGN, which is called the State Guardian Network. It's basically a tendermint DPoS-based chain, a relay chain. So there we have a group of decentralized validators that people can stake their Celer tokens on and kind of maintain the security of this decentralized validator network. And the validator network is going to watch all those on-chain transactions to kind of watch for those cross-chain transactions and validate their validity, and so that people can move funds around, and people can also pass messages around via this validator network. So the first component is our liquidity pool-based bridge. So basically, this is for more like blue chip assets, like say for example the stable coins and Ethereum. So we kind of use this like liquidity pool-based approach to maintain this liquidity pool-based bridge. And the second one is called the one-on-one peg bridge. So this is for essentially like any sort of ERC20 token we can support via this kind of like lock and mint process. And the third component is just the, which is sort of like the theme for today is the Celer IM, which is a generalized interchain messaging framework. And so this is basically just kind of expands what a bridge can do from just tokens to any sort of like generalized messages. We actually built the non-fungible token like NFT bridge on top of the Celer IM. And obviously like OPL leverages Celer IM under the hood. And we're going to talk about a little bit about that later. And so this like C-Bridge connects many EVM compatible chains, and very luckily Oasis Sapphire is one of them. So even though it has like privacy features built in, very fortunately it still maintains almost 100% EVM compatibility, so that we can very easily connect to Oasis Sapphire. And that's why like the OPL can leverage Celer IM very easily. It's sort of like this seamless connection between the two. So, so here's an architecture overview of how the entire system works. So, user like sends a on-chain cross-chain transaction via the application, and the application leverages, say for example, the C-Bridge SDK, which is our token bridge SDK, and like one of the gateway service, which is like a just for convenience, kind of listens to this on-chain transaction, and like all the validators on the Celer SGN is gonna like validate this transaction and say like, yeah, this is a valid cross-chain transaction. And now like the user's assets will be transferred from the user's wallet to the C-Bridge contract, and then this is on the source chain. And like after all the validators have like validated that this transaction happened, it's gonna like they're gonna give their signatures to kind of authorize the release of the user's corresponding asset on the destination chain. And this is sort of like a high-level view of how the entire system works. So we already touched upon this. So we have liquidity pool-based bridges for like tokens with larger liquidity, with like larger market cap, for example, stable coins and Ethereum. But for the majority of tokens, we use a like lock and mint kind of model, so that the users lock their original assets on one chain, and then the SGN network is going to help like authorize minting of the packed tokens on the destination chain. So here are some links to the token bridge we just talked about. Let me briefly go into this. Yeah, first off, this is like the UI for C-Bridge. So here you can see like where the source chain is, for example, like Oasis Emerald. Unfortunately, we don't have the token bridge connected to Sapphire yet, so I'm using Emerald as an example. So what a user can do is like they can say like bridge their like Celer bridged assets, for example, USDT or like Ethereum or USDC back to the Ethereum mainnet via this token bridge. So this is built on top of the C-Bridge SDK, which we're gonna look at very briefly. So yeah, we have a TypeScript or JavaScript SDK ready for usage, and you can just download and install it and like go through our examples. And we also have a set of APIs that you can like read the reference and sort of like integrate C-Bridge SDK into a project, so that your project can support this like seamless cross-chain token transfer. All right. Yeah, so I provided the links here. Provided the links here so that you can look at some of our APIs and try it out. So the next topic for today is the generalized messaging framework, which is called the Celer IM. So what it does is it supports sending generalized messages either with or without accompanying fund transfers. So basically, it can not only send generalized messages, but also you can like kind of bundle a C-bridge transfer along with the generalized messaging. So yeah, this is this is going to expand this like multi-chain user experience to not just tokens, but also to like DeFi's, GameFi's, NFTs, governance, and privacy solutions like OPL. So yeah, this is the workflow of how the generalized message works. So this is actually very similar to the previous workflow of a token bridge, even though it's kind of represented differently. So what we have here is a source app, which is like just a smart contract on a source chain. And the user is going to send a cross-chain message to the message sender app or the source app. And we have on each chain, we have this message bus smart contract that is both a message sender and a receiver. So the message sender portion of the message bus is going to like delegate that message to and to be registered with the SGN. So SGN is the validator, the decentralized validator network we talk about, which constantly listens to message bus for any kind of like incoming cross-chain messages. And like once we gather enough validator signatures for any cross-chain message, we're gonna issue a corresponding message on the destination chain. So basically, we also have a message bus smart contract on destination chain. And the receiver part of it is going to authorize a cross-chain message to the destination app, which is the, oh yeah. So yeah, the destination chain is, I think I was talking about the executor, which is a small component that kind of automates the entire process so that the user doesn't have to click anything on the destination chain to get the message received. Like we have a executor like which automatically executes any messages that has been authorized by the decentralized SGN network. So everything is automated and it's very basically this will support like this one-click user experience we talk about. So like the only click is like the user on the source chain sends this cross-chain message and everything else is automated. So I talk about like we support sending a generalized message bundled with a C-bridge fund transfer. So this is the diagram that shows that this workflow. So I think most of this stuff stays the same. It's just when the user sends a cross-chain message, they also indicate that they're going to send a like C-bridge fund transfer along with that. So we think this is a very common use case. So we kind of built this like workflow to just support that use case. So along with the message, we have this blue line, which indicates these like accompanying C-bridge transfer that goes through either the liquidity bridge or the PEC bridge. And on the so that's on the source chain. And on the destination chain, when the generalized message is authorized, the fund transfer is also authorized, and they're going to be like both the message and the funds going to be sent to the destination app, the message receiver app automatically. So I think we think like this is more a more powerful framework than just like supporting generalized messages. So by like also supporting fund transfer, I think it's especially useful for like DeFi applications. For example, like cross-chain swaps is going to be could be built very easily on top of this framework. So let me briefly show you what our documentation looks like for Celer IM. Yep. So we have quite a few examples on our doc site at im-docs.celer.network. So we basically have this dedicated doc site for Celer IM. So here we have a for those of you who are more technical, here is our very simple Hello World app for sending and receiving messages. So this message app is basically it's both a sender app and a receiver app. It's just the same app is going to be deployed on 2 different chains. So on the source chain, we have this send message function, which just takes a arbitrary message, and we specify a destination contract and destination chain ID, and then it's going to send the message via the message bus. We talk about a message. There is a Celer deployed message bus contract on each chain, and this app is going to interact with that contract to send the message to the destination chain. And on the destination chain, on the receiver side, we have this execute message, which is going to be called by the via the message bus contract on the receiving end. So the executor is going to call the execute message function on a message bus, which in turn delegates to this specific execute message call on the message app. So this is going to say in this very simple example, it's just like they're going to decode the message and then emit a message received event. So nothing more than that. But this is just a hello world. So we also have a slightly more complicated example. So that this is the second workflow I was talking about. So this is sending a message with a fund transfer. So for example, to support sending a token with a note. So we all know ERC20 doesn't support sending a note along with the fund transfer. But for this cross-chain ERC20 transfer, we actually support attaching a note to it, which is going to be very useful in many applications. So very similarly, we also have execute message with transfer. So this is going to execute the message and also at the same time transfer the required funds to the user on the destination chain. So in some edge cases, if the bridge fund transfer cannot be completed, we also support execute message, but the transferred fund is going to be refunded to the user. So this is for more like edge case and corner case handling. And we're not going to go into the detail. And we also support in order delivery of messages. I think this is very useful, especially for OPL. So for some use cases, the app is they want to require messages to be delivered in order. So in our basic Celer IM framework, we don't have that guarantee, but this is very easily fixed at the app level by introducing a sequence number. So we show example of how you're able to do that. And there are more complicated examples like a cross-chain swap and say an NFT bridge, which is quite useful. Yeah, so feel free to all of these are on GitHub, and feel free to just fork our GitHub examples and get your hands dirty with playing with Celer IM. And we also have a very comprehensive integration guide, which kind of walks you through all the steps, and it just assumes very basic Solidity knowledge, and we have basically step by step how you're going to integrate with Celer IM. So I think William has already gave a very thorough introduction of how OPL works, and I just want to mention that OPL currently uses Celer IM under the hood. but you don't have to understand like all of Celer IM. So this is like the slides before, and my talk is going to help you understand like how Celer IM works, but you don't have to understand how Celer IM works to use OPL, thanks to like a very good like abstraction made by Oasis. So yeah, the Oasis doc site has very great example of how OPL works, and it also talks about like briefly talks about like how it leverages Celer IM under the hood. And so yeah, you can also follow this example, which is actually quite useful. This is the privacy voting example that William was talking about. And if you follow this, I think you can build a very useful app based on OPL and Celer IM. Yep. So and this is just the same diagram that William already showed. So I won't go into the details. And last, I just want to say like happy hacking. And this has been a very, I say, fruitful cooperation between Celer and Oasis. And we're looking forward to like seeing your like various applications built on top of either OPL or IM or sort of both. So yeah, join our Discord dev channel if you have any questions. We have like tech support answering the questions there. Yep, so that's pretty much it for my presentation, and heading back to William.
Awesome. Thank you so much, Michael. I think everyone enjoyed learning a bit more about how Celer IM works, as well as, you know, some of the things that were, you know, differentiated from other bridging protocols, and basically what's going on underneath the hood when they're trying to build these Oasis Privacy Layer dApps for the hackathon. As you said, I think we've had a very fruitful collaboration thus far. And I'm just excited to continue working together. There were a few questions from the community, a few for Oasis, so I'll just take those now. So one of the questions would be, wouldn't multi-party computation be better in terms of working towards some of these privacy issues? So multi-party computation is like a very potent privacy solution. I think that the sort of things that we think about though are like, one, multi-party computation is very computationally expensive. And so, yeah, in terms of scaling an entire EVM network with like full composability, this is potentially an issue. The other issue would be that, you know, it requires a lot of communication between the different nodes on the network. And so you would necessitate sort of a lot of lag for transactions and for the network to sort of validate what's going on. And so for these reasons, we prefer the trusted execution environments approach. Again, the Oasis network is extremely flexible. So as like multi-party computation becomes more viable from both a latency and cost perspective, we can look into building up the supporting networks that offer that as a solution as well. We are using multi-party computation on some of our enterprise partnerships. Like, for example, our partnership with Meta AI leverages multi-party computation. So it's something that we feel very comfortable about it's a technology we feel very comfortable with. It's just at this moment, we think that, you know, the trusted execution environment approach is best for a composable EVM network. The second question, I think, is for you, Michael. It says, what are the fees like in terms of sending messages through Celer?
Sorry, could you repeat that?
So the second question was, what are the fees like when sending messages through Celer IM?
Yeah, that's a great question. So yeah, we do charge a very small fee for passing messages, and I think if we go back to this workflow here. So I talked briefly about this executor component that kind of automates the entire process. So that obviously, like, nothing comes free, right? So like for user to have this one-click experience, like the user still has to kind of cover the gas fee for the executor on the destination chain. So they sort of like pay this, they pay the gas fee on the source chain so that they don't have to like switch destination chain and kind of execute the message themselves. So yeah, there is a very small fee, and also like they kind of have to pay the running costs for all the decentralized validator network, which is the SGN. So yeah, but nothing like significant. I don't have the exact numbers, but I believe for each message is on the order of like cents, I think. So yeah, that is like the ballpark of what things are. Yeah, great question.
Awesome, thanks so much. And there was another Oasis question, roughly, I guess it says, how can OPL functionality be boosted? How can it be best leveraged for the cross-chain? So I think we talked about it a bit. I think Celer basically boosts the leverage of Sapphire. It basically enables EVM networks, any EVM network, whether it be layer 1, layer 2, to sort of offload their confidential computation needs to Sapphire. Sort of the framework that I think about it is like, if you remember, like when Polygon came out as a sidechain, basically the way it sort of was structured was to offload computation costs. So just like, you know, for dApps that, you know, or maybe not very high value, maybe some like NFT projects or something like that, where like security was not so much of an issue, but like basically like there was lots of transactions and lots of computations that were needed. Basically Polygon offered a viable solution for you to offload that your computation needs to them. Basically the Oasis Privacy Layer and Sapphire is enabling that through Celer. Is you can now have a dApp on any network and offload your confidential computation needs. So we talked about, I know the second part asks about like what are some of the best use cases or how it can best be leveraged. I think sort of the sky's the limit. Again, like the way I think about it is that like in Web 2, almost everything involves some level of privacy. You know, if you want to think about like Uber, right? If you wanted to build a Web 3 version of Uber, I'd be able to see every single place that every person goes. So what OPL and what Sapphire and what Celer together are all doing, it's enabling you to build sort of these modular applications so that you have like, let's say computation on one network, settlement on another network, and then your privacy needs somewhere else. So now that you can have maybe the settlement in fees paid on Ethereum for your Web3 Uber, but you can have the confidential computation done on Sapphire. Things like this. This is what I think the best use cases for. I mean, maybe that's an enterprise type use case, but you know, things that are sort of looking at these modular applications that the dApps don't have to be built in one ecosystem anymore, and they can sort of use the best parts of different ecosystems. That's, I think, the best way to use OPL. And the final question that I just have for you, Michael, is I know there were some questions around the executor. What's the best? I think your documentation mentions that people can get in touch with you in order to whitelist an executor. What's the best way to get in touch with the Celer team? What are maybe some alternative solutions? Maybe they can spin up their own executor.
Yeah, great question. So yeah, I think the best way to get in touch is either you just join Discord and you kind of like shoot us a message, and we'd be like constantly like monitoring that channel, and like anything, like any requests, you can like DM us and we can like talk about that. Or you can send an email to like info@celer.network, and I think we have a dedicated team to kind of like look at those requests. So yeah, so for the executor, I didn't go into too much details, but there are two options. One is like we have this like executor service. You just come to us and we're gonna like configure like our shared executor and to like add your destination app contract into it so that it's automated. But there's also this option to kind of like run your own executor. We have the executor. It's not open source, but I think the binary is open source. I could be wrong, but I think at least like you'll be able to like run the executor on your own. So that is also an option to just kind of have more control, and you can like even like customize some of the logic, I believe. Yeah, so yeah, we can talk about all those like business needs, like whenever like if you like join our Discord channel and like DM us or shoot us an email or anything, we'll be able to talk about those needs.
Yep, and I think that that's mostly relevant for mainnet, right? For the Oasis testnet, the sort of you can use the executor that's listed in the docs, correct?
Yeah, I think for testnet you can just follow the integration guide, and like I think it should talk about like running an executor and all that. So yeah, if you run into any problem, like the doc could be a little bit outdated. I'm not 100% sure, but if you run into any questions or like problems, you can just like talk to us, and we'll be able to fix them.
Awesome. Yeah, thank you so much. I think that was it for our questions. I just want to say thank you again, Michael, for your time today. I think myself, as well as all of our hackathon participants, will greatly benefit from this information. And I'm just really excited for this partnership and this collaboration, as well as this hackathon, to see what sort of new applications, new ideas are built, and sort of how we can start advancing the Web3 space. So I think in terms of the Oasis side, if you want to keep an update with the hackathon, as well as maybe some more events that we're having with some of our other partners, follow us on Twitter, join our Discord. We're constantly promoting all the events that we have, and hopefully we'll see you all there in the future. Just want to give you a second to give your last minute thoughts on anything going on with Celer, Michael.
Yeah. So. Yeah, we've been working both on the bridging side, like on cross-chain operating system, but also like we're expanding into this new area, like which is the area of ZK and like also privacy computation. Yeah, it's very interesting that Oasis took the TE approach, which is like very easy to scale and like very easy to support like a full like EVM compatibility. But like we're more into this like more I guess crypto heavy ZK based like Snark based solution, and we're exploring that with our new effort called Network, which is this like cross chain, like omni chain data attestation platform, data attestation framework based on ZK Snark technologies. Yeah, and if you're interested, more like hardcore like cryptography guy, you can like check the Network and read our like white paper and like try our little like demo for ZK bridge, like ZK message bridge. And I think at some time we might be able to like integrate this like ZK Snark based solution with the TE solution, so like you can have like best of both worlds kind of solution, and that would be very awesome.
Yeah, I think we talked a bit about Brevis on a Twitter space recently with Celer. It's definitely something that the Oasis team is keeping an eye on. Specifically, Harry from our team is in love with Brevis and is itching for any more documentation or any more information you guys have. And yeah, looking to integrate it when that gets to the stage that makes sense to do so. So for anyone who's interested in ZK bridging or ZK attestation, definitely check out Brevis. It's a really cool piece of tech, and the Oasis team is definitely going to be paying attention. Anyway, thanks everybody for the time, and I hope you guys all have a great rest of your day, and I hope to see you guys at the next event. Bye-bye.